Alright, my little math friends, we are back, and now we're on the very last part of Chapter 7, 7.2, and we're going to be writing and solving two-step algebra inequalities using real-world problems, okay? Again, with these word problems, the most difficult part with inequalities is trying to figure out what sign you're going to use, whether it's less than, greater than, or equal to, trying to figure out that sign. The wording can be kind of tricky with those, okay? What I like to think about is I like to think in terms of a minimum or a maximum, okay? And I'm going to point those out as we go along because minimum and maximum makes more sense to me than some of these other words that we're seeing, so maybe that'll help you guys out too. Alright, let's take a look at this first problem. This first one is a real doozy, a tough math problem. I put the hardest one first, and then the other ones will get a little bit easier, but let's tackle this one first. First step, guys, we got to read through the problem, alright? A mountain climbing team is camped at an altitude of 18,460 feet on Mount Everest. Okay, so get that picture in your mind. The picture helps out. The team, this should be team, the team wants to reach the 29,029 feet summit in no more than 6 days. How many feet must they climb each day to reach this goal? Okay, now we need to underline the question. Alright, we want to find out how many feet they must climb each day. So they got 6 days to do it. How many feet they're going to climb each day to get to the top of the mountain. Okay, let's identify our facts. We know that they are right now at 18,460 feet. Okay, we know the total amount they have to climb to get to the top is 29,029 feet. And they want to do this in no more than 6 days. Okay? Number 4, we're going to name the variable, look to the question. We're trying to find out how many feet they must climb each day, each of these 6 days, to get to the top. Okay, so let's use F for the feet. Okay, that's what we're trying to find out. Now we're going to build the algebra problem. Okay, here comes the tricky part, building the algebra problem. Alright, on this side of the equation is the total that we're trying to get to, what they're trying to do. They're trying to get to this elevation, 29,029 feet. Okay, this is the top of Mount Everest. Okay, over here is going to be the math for them to get to the top of Mount Everest. Okay, so let's set that up first, then we'll worry about our sign. So the math to get them to the top of Mount Everest is, we know that they are at 18,460 feet right now. Okay, and they need to get to, or they're going to hike another 6 days. Okay, there's our 18,460 feet, and they're going to add 6 days of hiking, and each day they're going to climb a certain amount of feet, and that's what we're going to find out. So it's going to be 6 days times the number of feet is going to get us to the top of Mount Everest. Okay, now let's try and figure out what type of sign is going to go here, what type of inequality. Take a look at this. No more than 6 days. Okay, so they don't want to go over 6 days of hiking to get to the top. If they do it in 5 days, that's fine. If they do it in 7 days, that's not going to work for them, okay? So no more than 6 days. 6 days is their maximum. Okay, they can't go over 6 days. Okay, so when deciding what type of sign to put here, this over here is their hiking. Alright, so when we find out what number f is going to be, when we solve for that and find out that number, when we add this up over here, this has to either equal 29,029 feet, or this has to be over 29,029 feet, so that they reach the top. Okay, if we come up with a number for f, and if it is less than this number over here, that means they didn't reach the top. If we get like 28,000 when we add this up, that means they did not reach the top in 6 days. Okay, so our sign, the tricky part is that this side over here, when we add up this math, it has to be greater than or equal to the top of the mountain. Okay, when they get done hiking, they either have to be at the top, or this has to add up to over this amount to show that they got it done in less than 6 days. Okay, that's the tricky part, is coming up with that sign there. Okay, now let's just do some algebra and we will solve this. We're on step number 6. Alright, so we got to take away 18,460 over here to get, there's my numbers. That looks a little bit better. Cancel that out over here. Okay, now we're going to do the same thing over here. We're going to take away 18,460 on this side. Okay, I got my numbers right on that one this time. Gold star for me. Now let's go ahead and subtract this. 29,029 feet minus 18,460 feet. We are left with 10,569 feet. Alright, drop down what we still have left, just like a regular algebra problem. We still have 6 times f. Okay, so it's 6 days times the number of feet. So to solve for this, we got to divide by 6, divide this side by 6, and when we do that, the amount of feet is going to come down to 1,761.5 feet. Okay, so what we just said is the amount of feet they have to climb each day either has to equal exactly this amount to reach the top in 6 days, or it can be greater than this amount and they'll reach the top in less than 6 days. Okay, that's what we just said by solving that. Now we're going to check our answer to see if this is going to be correct. Okay, so let's use f can be greater than or equal to this number. So let's just use a number greater than it. Let's say they want to climb 1,800 feet each day. Okay? So if we work out the math on that, if we plug this number in for f, and if we go 6 times 1,800, we are going to get 10,800. Okay? We would get 10,800. And if we add 10,800 to this 18,460, we would get 29,260, okay, which is perfect. That means that they actually made it to the top in a little bit less than 6 days, all right? So I hope that helps out trying to come up with what sign to go here. If it doesn't come to you guys right away, don't worry about it. This is hard, trying to figure out what sign goes there. That's the toughest part about inequalities, okay? But we're going to keep getting practice on this. You guys will get better and better. But don't feel bad if you're not getting it right away. It takes time, and it's just it can be confusing trying to figure out what sign to put there. Alright, let's move on to some simpler ones. Now that we got that one out of the way, let's check out a few more and we'll see if they get a little bit easier picking this out for us, okay? Step number 1 on this problem, we're going to read through and get a picture in our mind of what is happening. The 45 members of the Glee Club are trying to raise money so they can compete in the state competition. Okay, so get that picture in your mind. So far they've raised $215. They need at least $4,760 to be able to attend. How much money does each member need to raise in order to attend? Okay, so we read through the problem. We have an idea of what we need, what is going on. Let's underline the question. We need to find out how much money each member needs to raise in order to meet this goal up here. Okay? Identify our math facts that we're going to use. Alright, we know that we have 45 members in the club. We know that they have this much money so far to go to the competition. They need at least this amount to be able to attend. Okay, so there's our math facts. Let's come up with our variable. Let's name the variable. Look to the question. It'll tell you. We need to know how much money does each member need to raise. Okay, so let's just use M for money. We're trying to find out how much money each person is going to have to fundraise. Now let's go ahead and build our algebra problem. Alright, over here on this side, we need the total that they're trying to get to. They are trying to get to $4,760, and then over here is going to be the math to get to this total. Okay, so let's use our math facts that we came up with. We know that they have $215 right now. Okay, they have $215. Then they're going to do some fundraising, so they're going to add some money to that. And each person is going to fundraise. So every person, all 45 people, are going to raise a certain amount of money each to get to this total. So it's going to be 45 times the money that they raise to get to this. Okay? Now we just need to figure out what symbol to put in right here. What type of inequality? So take a look at this. They need at least this amount. Okay? If they have over this amount, if they have like $5,000, that's fine. If they have less than this amount, that is not going to work. Okay? So this is the minimum amount that they need. They need at least that. If they get over it, cool. If they get under it, well, there's going to be some sad Glee Club people. Okay, so they need at least that. So what that means is the math over here on this side has to either be equal to this, or it can be more than this, which would mean they would get more money. So our symbol is this math over here can be more than or equal to this total that they're trying to get to. Alright, now let's just work this puppy out and try and solve this and see how much each person needs. We need to cancel off the 215 first. Cancel that. Take 215 away over here. Draw your big line across here so you can keep yourself organized. 4,760 minus 215 is going to get us 4,545. Alright, drop down what we still have left. We still have this symbol, and we still have 45 times M. Alright, now let's find out how much each member needs to fundraise. So we're going to divide by 45, cancel that, divide this side by 45, and when we do that, M is going to be greater than or equal to $101. So what this solution means is that the money each person raises can be equal to $101, which would get them exactly this goal, or it can be over $101, which means we give them more money. Okay, we just solved this inequality. Now let's check our answer to make sure it matches the story problem. So since the money can be more than 101, let's just use a number. Let's just say, what if they raised $110, and let's see if this works. Okay, so if we put 110 into this math problem, if we go 45 times 110, we would get 4,950, okay, which is perfect, alright, because even with that amount, adding the 215, we are already over this goal, and the club can go on the trip. And it makes sense, because if they did do 110 each, they would have at least this amount and even over that amount. Okay, so our story problem kind of worked out that way using that symbol. Alright, let's check out another one. I got one more for us to solve here, and then I'm going to move you on to a try this problem. Let's go ahead and read through this. Ella has at least $40 to spend at the state fair. Admission is $7, and each ride costs $3 each. How many rides can Ella purchase? Okay, get a picture of that in your mind. Let's underline the question. We want to know how many rides can Ella purchase at the state fair. So now we're going to identify the math facts. We know she has at least $40 to spend. Okay, she's going to spend $7 on admission, and each ride is going to cost her $3. Alright, let's name the variable. Let's use R for rides, because we're trying to find out how many rides that Ella can go on. Now we're just going to build the algebra problem. Okay, so over here we're going to have the total that we're going to get to. Okay, we know she has at least $40. Okay, so we're going to put $40 over here, and then over here we're going to show the math that is going to get us to this total of $40. Okay, so the math, we have admission is $7 that she has to pay, plus she's going to pay $3 for each ride, so it's going to be 3 times R, and that's going to get us $40. Alright, now let's just figure out what type of symbol we need to put in between here to make this work. We know that Ella has at least $40. Okay, so $40 is the minimum amount that she has, because she can it says at least $40, so she could have over $40. She could have like $50, but she does not have $30. It tells us she has at least 40. She might have more, but her minimum amount she has is 40. So our math, this side over here, can either equal 40 when we come up with a number for r, or it can be over 40, which is totally fine. We just can't have this side be under the $40 over here on this side. So our symbol is going to say that this side needs to be greater than 40 or equal to 40. Okay? Now, let's just go ahead and solve this and see what we get. We're going to cancel out the 7 first. Minus 7 on that side. Do the math on that. We get 33. Bring down your symbol and bring down 3 times r. Now we just need to cancel out the 3. You guys can probably even see the answer right now. Divide by 3. Divide by 3. Okay, the amount of rides she can go on. Oops, I put an equal sign there. I'm thinking chapter 6. Sorry about that. We need this symbol. And the amount of rides that she can go on is equal to 11, or she could go on more than 11. Okay, so now let's just check to make sure this works. We could go with more than 11 rides. Let's just stick with 11 and we'll just make sure that this works. Okay, so if we put 11 in here for the rides, 3 times 11 would be 33. Add 7 to that. That would give us 40, and it matches what we came up here. 40 is equal to 40. Okay, so perfect. That one worked out. Alright, try one on your own. See if you can come up with what symbol is going to go in between your two sides of the equation. Set it up, and then check back in with me, and we will see how you guys